So today we're taking a quick look at greatest common factor and our three strategies that we can use in order to find it. If you remember from in class, our first method was our list or rainbow method. So in the rainbow or the list method, remember you're taking both numbers and you're just listing out all of their factors and finding the largest shared factor. So if we're trying to find the GCF of, say, 64 and 96, what we would do is just list out each of their factors. So for example, 64 would be 1 and 64, because 1 times 64 is 64. And then it would be 2 times 32. 3 doesn't work. And then it would be 4 times 16. And the last one would just be 8 times 8. So you just list 8 once. So those are all the factors of 64. Not too bad. And then we do the same for 96. So 1 and 96. 2 times 48. 3 times 32. 4 times 24. 6 times 16. And then we have 8 times 12. So I kind of ran out of room. And then I just start at the left and I look for what's the first thing they have in common. So like 64 doesn't appear in 96, but 32 does. So their greatest common factor would be 32 because it's the largest factor that they both have in common. If you look, they would also have 16 in common, 8 in common, 4 in common, and 2 in common. So those are all the common factors, but 32 is the greatest. This method works well, especially for smaller numbers. However, when you start getting into bigger numbers, it's really easy to accidentally miss factors, and so you have to be really careful with it. So that's the rainbow or the list method. Our second method that we discussed in class was our prime factorization. This was using the factor trees. If we look at those same two numbers again, we can kind of just compare how it looks. So we have 64, and you can break this up any way you want. So for example, I know that 64 is 8 times 8, and then each 8 would be 2 times 4, which would be 2 times 2. I just like to circle my prime factors so I know my branch. Each branch is done. And I do the same thing for 96. So 96 I know is 8 times 12. So I have 2 and 4, which would be 2 and 2. 12 would be 3 and 4. And now, with prime factorization, we're going to take each of them and list out their prime factors. So 64 is 2 times 2 times 2 times 2, or 6 2's. And then 96 ends up being 2 times 2 times 2 times 2 times 2 times 3. And now I'm going to circle anything they have in common. So in this case, they have all these 2's in common, and then I'm just going to take one of each of what they have in common. So here they have a 2 in common, a 2 in common, a 2 in common, a 2 in common. And I'll multiply all those. So 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. Same greatest common factor, but just another way to find it. So that's the prime factorization method. The big thing here to remember with the prime factorization is that you're only listing one for each set of numbers that you circle. And we use 2's here because that's what they had in common. Had they had a 3 in common, that's what we would have circled. So that's the prime factorization. And our last method is my favorite because it's the cake method. I just like this method because I think it goes fairly quickly because you're breaking down both numbers at the same time. So I'm going to start with 64 and 96 again, just to give you that look at that same thing. I draw my first layer. And like I said, the thing I like about this is that you just pull out any factors that you realize. So it might be that you realize that 64 and 96 are both even, so you're going to pull out a 2. 64 divided by 2 gives us 32, and 96 divided by 2 is 48. I'm going to draw that next layer. They're both even again, so I might just do a 2. 32 divided by 2 is 16. And 48 divided by 2 is 24. Now maybe I realize, oh hey, I know that a 4 goes into 16 and 24. 16 divided by 4 is 4. 24 divided by 4 is 6. And then I look and I say, oh look, another 2. So now I have 2 and 3. I'm going to draw that last layer on, and now the only thing they have in common is 1. At this point, I'm going to take all those numbers along the outside that I pulled out and multiply them. So 2 times 2 times 4 times 2 times 1, and really the 1 wouldn't matter. So I have 2 times 2 is 4, times 4 is 16, times 2 is 32. So our GCF is still 32. I'm going to give you one more look at the cake method using different numbers just so it's not 2 and so you have an unfamiliar problem to look at. Just because I want you to have another look at it. So what if we had the GCF of 150 and 225? Now you could of course use any of those other methods. And if you want, you could go ahead and pause the video and try any of the methods and then just check your work after you're done. I'm going to show you using the cake method. Here's my first layer. Since they end in 0 and 5, I'm going to go ahead and I'm just going to say I know that they can both be divided by 5. So when I do that, I have 150 divided by 5, and I get 30. And then I have 225 divided by 5, which is 45. Draw my next layer. 30 and 45, once again, end in 0 and 5, so I'm going to pull out another 5. 30 divided by 5 is 6. 45 divided by 5 is 9. Draw another layer. Now when I look at 6 and 9, I know that 6 can be broken into 2 and 3, and 9 can be broken into 3 and 3, so I can pull out a 3, leaving me with 2 and 3. So now my GCF is 1. I'm going to multiply these numbers on the outside. 5 times 5 times 3 times 1. So 5 times 5 is 25, times 3 is 75. So the greatest common factor of 150 and 225 would be 75.